Hello everyone. Before you start the lesson, try the warm-up. Factor fully. So factor this expression. Evaluate. Try not to use a calculator because the rules that you follow to add and subtract fractions is what you need to remember for this lesson today. So try all this and see how you do. Pause the video. The common factor of these three terms is 2. I'm left with a simple trinomial, which I can factor like this. When you're adding and subtracting with fractions, remember you have to have a common denominator. So you have to manipulate one or both denominators so that they end up being the same. In the first one, I notice that I can just multiply 7 by 2 to get 14, then both denominators are 14. But if I change the denominator, I have to change the numerator by the same amount. So that's where this came from. 6 over 7 is equivalent to 12 over 14. So when I subtract 12 over 14 minus 3 over 14, well, 12 fourteenths minus 3 fourteenths is 9 fourteenths. Over here, I want to highlight this. If I need to get a common denominator, just multiply this denominator by the other one and multiply this denominator by the other one. If you do that and you do the same thing you do in the numerator, then you'll end up with a common denominator and you can just add your fractions together. This right here is a valuable skill that we're going to use in the current lesson for today. So if you need a common denominator, you need to multiply each denominator by the other denominator. That's going to come into play when we are adding and subtracting rational expressions. Remember, these are expressions that are fractions. But if you're going to add and subtract fractions, you have to have a common denominator. And we're going to do that today with lots of algebra. So here's the first example. We're going to simplify this expression, and then we're going to state any restrictions. When I'm adding fractions, I have to have a common denominator. Well, I notice I don't have a common denominator. So what do I have to do? How can I manipulate these so that they are the same value in the denominator? Well, I'm going to use that same trick from the warm-up. If I multiply this denominator by 3 and this denominator by 7, I'll end up with 21x as the denominator in both fractions. And I have to do the same thing to each numerator, and I end up with 9 over 21x plus 14 over 21x. And now that I have a common denominator, I can just add these directly. I end up with 23 over 21x. So that's simplified. Let's state any restrictions. Well, right off the bat, we got to look, what can x not be? Remember, the denominator cannot equal 0, which means x can't equal 0. And all the way through, x just cannot be 0. So I got to write the restriction at the end. Here we're subtracting fractions. So remember, we need to have a common denominator. So you can think, what would I need to multiply each denominator by to make them equal? Pause the video and see if you can figure this out, and then try to simplify it as much as you can. Well, if I multiply 10m by 15m, I get 150m squared. If I multiply 15m squared by 10, I get 150m squared. And I'd have to do the same thing to each numerator. I end up with these numerators. So now that I have a common denominator, I can just subtract this from this. Notice here I'm subtracting 10m, so that's minus 10m, and I'm subtracting minus 60. That's where the plus 60 came from. Now I am just going to clean this up a little bit. I'm going to collect my like terms and simplify. And once I've done that, now I can actually start factoring and crossing out factors that I see in the numerator and denominator. Well, there's a common factor in the numerator of -5. And this part here, 3m squared minus 7m minus 12, you might be wondering, why didn't I factor that? Well, if you did this, maybe you figured it out too. I can't factor this. 3 times minus 12 is minus 36. So I need to find two numbers that multiply to negative 36 and add to negative 7. Well, if you write out all your possibilities, you're not going to find any that work. So we can't factor this further. This is as far as I can go. And the 5 cancels with the 150 that goes in 30 times. So 5 over 150 is the same as 1 over 30. So we simplify that, and we end up with this simplified expression here. As I track all the way through my solution, the only restriction on m is that it can't equal 0. So that's the only restriction. Remember the key idea here. When you're adding or subtracting fractions, you have to have a common denominator. So you have to manipulate the denominators to make them the same. And once you do that, you can add or subtract your fractions together, factor, and simplify. Now this one's a little bit different because we just have expressions in the denominators and numerators. We're still subtracting, so we still need to have a common denominator. But this time, think of it more like this. Sometimes when people see the brackets around the numerators and the denominators, they can see what I'm about to do more clearly. Here the denominator is x plus 5. Here it's x minus 3. So if I took this denominator and multiplied it by this denominator and do the same thing on the other fraction, this denominator times this denominator, I would get the same thing. This is what I mean. X plus 5 times x minus 3 is the same as x minus 3 times x plus 5. Now we have a common denominator. So when I do the subtraction, I end up with this as my numerator. Now what you don't want to do is to start canceling at this point. You might think, oh, x plus 5 here cancels with this x plus 5. This x minus 3 cancels with this x minus 3. But you can't do that. Here's an example of why. Here's an expression, 5 times 3 minus 3 divided by 5. If I do it properly, 5 times 3 is 15. 15 minus 3 is 12. 12 divided by 5 is 2.6. Now, if I do it the way I was just explaining, like this, cross this out with this and this out with this, that's what I'm doing here. That 5 cancels with that 5. I'm left with 3 minus 3 on the top, 1 on the bottom. 3 minus 3 is 0. Divided by 1 is 0. You can see I get totally different answers. This one is wrong. This is incorrect. Don't do that. Okay? Please, don't do it. You have to expand and simplify this first, and then factor it, and then start canceling out. So when you expand this, you get this. When you expand this, you get this. Now I'm going to subtract each of these terms, and I end up with this. X squared minus x squared is 0. Negative 5x minus 9x is negative 14x. 6 minus 20 is negative 14. Now when I factor this, I end up with this. Negative 14 is the common factor. I have x plus 1 as the other factor. All right, this is now simplified. Let's keep track of what our restrictions were from the very start all the way through. X cannot equal 3 or negative 5. Now here's one more example. I'm going to ask you to try this on your own. First, you're going to have to factor each denominator. Then you can decide what you need to multiply each denominator by to get a common denominator. And then you can proceed like we did in the previous example. So simplify this, state any restrictions, and let's see how you do. Here's how I got it. This factors to this factors to this. X plus 1, x plus 2, and x plus 3 need to be in the denominator. So I'm going to multiply this by x plus 1. I'm going to multiply this by x plus 3. Now I have a common denominator. I'll add my numerators together. expand and simplify, I get this. Now factor it again, I end up with this. I don't have any factors that cancel out, so I'm done. And I kept track of all my restrictions. X can't be -1, -2, or -3. And now it's time to practice all this. It's a lot of algebra, but if you keep the fundamentals, you got to have a common denominator to add and subtract fractions, then you can do this. You also have to have strong factoring skills, which comes with practice. So you got to do more and more practice all the time. And if you have any issues with any of this, please reach out and I will do my best to help.